So finally in this video, we're going to start talking about how big of a sample do I really need? Well, in order to answer that question, I have to know a couple of things from the person before I can answer that question for me. One of the first things I need to know is about what are you okay with your margin of error being? Do you need to be within 1%? Or are you okay with being off by 2%? So in a sense, how far off from the true proportion are you okay with being? So that I need to know first. How far off do you want to be? Secondly, I need you to tell me how confident you want to be. Do you want to be 99% confident, or are we okay with just being 95% confident? So I need you to be able to tell me those two things. And if I know those two things, I can help you determine how big of a sample do you need. What we do is we have to set our margin of error to be no bigger than that number we actually calculate for the margin of error, and then we take this formula and solve it for n. And please note that this formula is on your formula sheet, so you don't actually have to go through and doing the solving for it. But what we're going to find is that our n needs to be at least as big as z divided by the margin of error, all squared, and that's the easiest piece to miss, is that little squared piece we have here, times our p hat times the 1 minus p hat. So if we look at this formula, there's a couple of things that should stand out. If you tell me what you want your margin of error to be, okay, I'm okay, I'd figure out how to plug that number in. If you tell me how confident you want to be, well, we've discussed that your confidence will tell me your z, so I have that to plug in as well. But you didn't tell me anything about this p hat. So what do we need to do about p hat? Well, first of all, why do I need to do anything about it? Well, p hat is our sample proportion. How do I have a sample proportion before I take a sample? Right, so once I take my sample, I can know my sample proportion, but I'm trying to figure out how big a sample I need to take, so I probably haven't taken a sample yet. Okay, so what things could we possibly do? And I usually try to do them in this order. The first thing I would like to be able to do, if I can, is I can use my sample proportion from a previous similar study. For example, maybe lots of businesses do the exact same study year after year after year, so I could use last year's p hat to help me estimate what this year's p hat would be. And that seems like a pretty reasonable replacement, right? If I'm doing the same thing, I can just replace it with my previous one I had. But what if you're doing something brand new that's never been done before and you don't have a p hat from a previous similar study to use? Well, what we use if we have nothing else is we use a p hat of 0.5. Now you may ask yourselves why. So the reason we would use this if we don't have anything else is it results in the largest possible sample size. So what I mean by that, if you plug in anything but 0.5 for p hat, you will get a smaller n than if you plug in 0.5. So 0.5 will give me my largest possible value here for n. So in a sense, it's your safe bet. It'll always cover you. So our goal next is just try to apply this formula to a couple of problems, and we'll see how we feel. So for example 3, we're doing a news poll, and we want to estimate the proportion of people who believe in ghosts. We want to figure out how large our sample should be so that the margin of error will be no more than 1% with 95% confidence. So here's those two things that I just told you that someone has to tell me. So I want my margin of error to be no bigger than 1%, but I've got to change that to a decimal. So 1% divide that by 100% will give me 0.01 for my margin of error. That confidence level is going to help me find my z. So if we are 95% confident, and we go back to our little chart here, we'll see if we're 95% confident, we use a z of the 1.96. So that's what we're going to plug in for our z. The last thing I need to figure out is what I should use for p hat. From reading what I've got here so far, I don't see anything from a previous similar study for me to be able to use, so that's what I'm going to use, that 50%. Because again, at least from what I can see, there was no prior study done for me to be able to use something else. So now I have my three values to be able to plug into my formula. I know my z, I know my margin of error, I know my p hat, and I'm trying to solve for n. So my n will need to be at least as big as our 1.96 over our 0.01 all squared times our p hat times the 1 minus p hat. And if I do my math, we should get 9,604 people. So if the ABC News poll is able to sample 9,604 people, they'll be good. Now they could figure out, well, maybe I don't have the time or the money to sample 9,604 people. I need to do less people. Then they're going to have to figure out, what are they willing to sacrifice? Are they willing to have a larger margin of error? They wanted to be within 1%. Are they okay if I change that to 2%? Or are they okay with maybe being less confident in their answer? So I could ask them to change one of those two things, or possibly both, to help them get a smaller sample size if this number is not achievable for them. Right, another example. So in a small study, we found that 80% of graduating seniors plan on going to college. We're trying to figure out how large a sample should be taken so that our margin of error is no more than 1.5% with 99% confidence. So there's those two numbers that I have to be given. So my margin of error is that 1.5% as a decimal, so dividing by 100% will give me a margin of error of 0.015. The 99% confident just tells me to use that little chart to get my z of being at 2.576. And then finally, what should we do about p hat here? Well, this time I actually have a study that's doing the same thing here, so I can actually use that 80% for my p hat. Applying the same formula with just some different numbers. So our z was 2.576. Our margin of error was 0.015. Then squaring that value times our p hat times our 1 minus p hat. Doing our math here, we should get 4,718.77. But here a decimal doesn't really make sense because we're talking about the number of graduating seniors. I can't sample a partial person. So the question might be, should I round up or round down? In the case of sample size, no matter what this decimal point is, we're going to round up. And that's the reason why I write this formula the way I do. N has to be at least as big as this number. So if I have to sample part of that person, even if it's only 0.01 of that person, I have to sample the whole person. So sample size will always round up to the next whole person here and sample 4,719 graduating seniors. Now, just as a side note, I said when we use a p hat of 0.5, we get the largest possible sample size. So if we would have not had that 80% to use here, what would have happened if p hat was 0.5? What you would have found here is that your n would have to be at least as big as 7,374. that is a very drastically different sample size. So when we have that prior estimate, we like to use it because it's going to result in a smaller sample size. In your last video, you're just doing an example of tying everything together.